Right. So we discussed about how to draw the various shapes like square, pentagon, hexagon, like that. So now we will see how to draw the isometric projection of the solids. So again you have to keep in mind that when the question says isometric view of a solid, then you will have to take the actual size. When the question reads isometric projection, you have to take the isometric scale. In the sense, the size will be slightly lesser than the original size. Right. So now we'll see how to draw the isometric view of a square prism whose side is 40 and height is 60 millimeters, and the prism rests on HP on one of its ends such that one of its rectangular faces is parallel to VP. So because when it resting on HP, it can rest like this, it can rest like this, it can rest in any position. To fix the position, the additional constraint that's given is one rectangular face parallel to VP. Of course, being a square prism, if one face is parallel, the other face is also parallel. They can also ask in the other way, instead of saying that one rectangular face is parallel to VP, they may also say that one of the rectangular faces is perpendicular to your VP. So either way they can ask, but in both the cases this prism will rest like this. So before starting to do it, we have to draw the orthographic view of the solid, the front and top is of the solid, and then move on to the isometric view. So this is the top view of the prism, which is a square. Right, so this is the front view of the prism. Now we will draw the isometric view of the square prism. So because the base is a square, that will automatically become a rhombus, and since these lines are isometric lines, we are not enclosing it in a box, straight away you are drawing the isometric view of this base, which is a square. So if you look at this, ABCD is the top corners of the prism, and 1, 2, 3, 4 is the corners of the base of the prism. So this is the base of the prism, so I have marked it as 1, 2, 3 and then 4. So now, if you look at the front view of this, you have vertical lines or the vertical edges of the prism, and we know that in isometric view the vertical lines will always remain vertical. So how many vertical lines will be there for this square prism? So there are 4 vertical edges, means there are 4 lines in that. And what will happen to the height of that? It will be the same. So now what you have to do is, from all these 4 corners, erect vertical lines which will be equal to the height of this prism. So in which case here it is 60 millimeters. So we got 4 points, and those points will be your A, B and C, D, which are the top 4 corners of that. So when you join them, you will get the top face of the square prism. Now the final answer, which are the edges that will be visible, that you darken it, and that will be your final answer. So the one which is given in a pink color is the final answer. And if you compare this with the projection of solids, where you will usually we used to show the hidden lines and the visible lines separately, whereas here in isometric view or isometric projection, we are not concerned about the hidden lines, because what we want is the 3D or the pictorial representation of the object So we are not concerned about hidden lines, and you need not explicitly show the hidden lines. So this is the isometric view of a square prism, and again as I told you, these two are inclined at 30 degrees each, which I am not explicitly marking it there because it is understood it's isometric view, it will be only 30 degrees. So now we will see how to draw the isometric view of a pentagonal prism of base height 40 and height 60. As I told you earlier, the orientation of the prism or the initial position of the prism is very important, and that is where the additional condition is given that one of its rectangular faces is parallel to VP and away from it. By two conditions, parallel to VP and also away from it. So because if you say one of the rectangular faces is parallel to VP, there are again two possibilities. So if you look at this diagram, so the diagram 1 where the rectangular face is parallel to your VP and away from it, and in diagram number 2 you can see the rectangular face this also is parallel to VP, but this is near to VP. So that's why you have to be very careful about the initial position. When it says away from, this is the correct orientation, and this you should not use it. So now we will see how to draw the isometric view, and as I told you, usually we draw the front and top piece of the prism and then move on to the isometric view. So here I have drawn the top view of the prism, which is a pentagon, and since we have non-isometric lines, we have to use the box method, and I have enclosed the pentagon in a box which is named as PQRS, and the front view is given. Of course, in case of prisms, necessarily you need not draw the front view because we know it's going to be a vertical lines of length equal to the height of the prism. So this is the base. So what we will do first, we will draw the base isometric view of the base of this prism, pentagonal prism, and then construct the full prism. So I need not to say this will be inclined at 30 degrees to the horizontal, and this is my PQRS is the enclosing box, right? The isometric view of this enclosing box. So now what we need to do is transfer these points 1, 2, 3, 4, 5 to the isometric view. So measure this distance B2, measure this distance P2 and transfer it here. Again it's a regular pentagon, so P2 and Q3 both will be same, so I can measure this distance using a divider and transfer it there. Right, so this is your 2, 3, and measure this distance P A here or P1, and again being a symmetric, a regular prism here, this and this will be same, so you can measure this in a divider and mark it here. And finally you have to mark this point E5, or of course the base of it will be 5, and this is midpoint of your SR because it's a regular prism here. Measure this distance S5 and transfer it here. So now you have got the base of the prism. Right? And now we need to construct the prism over this. And again here, being a prism, it has got vertical edges, or the longer edges, and since they are vertical, they will be vertical here also, and the height of that, the length of these vertical lines will be equal to the height of the prism. So from all these 5 points, erect vertical lines which will be equal to this, and then finally you can join it. In fact, one more thing I want to say at this point, whenever you have a non-isometric lines like this, we enclose it in a box. Box in the sense could be a square rectangle. The other side, in isometric, you assume that you enclose the entire solid in a box, 3D box, right? So in which case, both the ways you can do it, I'll tell you, from all these 4 corners, you erect verticals equal to height of the prism here. So which will represent the top face. Now what you can do is take this measurement, of course it is the same measurements, and mark it on this face. And join them in sequence. So this is the top face of the prism. Now connect them to the so this is the isometric view of a pentagonal prism. So again, as I told you earlier, so there are hidden edges which we are not concerned about. What we want is the pictorial view of this pentagonal prism, and this is the prism. Right, now we will see how to draw the isometric view of hexagonal pyramid whose base side is 40, height 60, and this is the dimensions for the solid. And then what are the additional conditions that are given to place the orientation? It says two of its base edges are parallel to VP. So that is, for this condition you have to place the pyramid in position. So now I have drawn the top view of the hexagon here, and if you look at this, of course hexagon has got a non-isometric lines. I have enclosed it in a box. Right? So we need to ensure whether this view meets the given conditions. The condition says two of its base edges parallel to VP, and if you look at this diagram, FE and BC are the two edges which are parallel to your vertical plane. So sometimes the problem could be the other way. Two of the base edges are perpendicular to VP. So that is also possible. So now for this given condition, we will see how to draw the isometric view of this hexagonal pyramid. So as usual, you draw this box over the isometric view of this box P, Q or S. So we have drawn the isometric view of this, and now transfer these points A, B, C, D, E, F onto that. So how do you do that? Of course, measure PB. Again, this is a regular hexagon, so PB and QC will be same. Take this distance in again PB, SF, RE, all four will be the same distance. So you can take one measurement using a divider and mark all the 4 points. And mark B, C, E and F. And next we need to find A and D. So again here being symmetrical, PA and QD will be equal. So take this distance in a divider and mark it there. Right. So we have got all the 6 corners of the base of the hexagon. Next, what we need to do is we need to draw the apex of it. So to draw that, first we need to mark the center of the base on this isometric view. So how do we do that? So when you draw lines here, so measure this distance and transfer it here, and measure this distance, it's already there. So draw a line parallel to this, and draw a line through this point parallel to this. So this will give you the center of the hexagon. Now from here, so in case of prisms you have the vertical edges, in case of pyramids you have the axis. Again, axis is, though it's imaginary line, still it is a vertical line, or it is perpendicular to the base. So the axis being a vertical line, it will also be a vertical line in the isometric view. So what you have to do is, from this point erect a vertical equal to the height of the pyramid. This is my apex. And once I have marked the apex, then connect the apex O with all the corners. And then darken the visible edges. So this is the isometric view of the hexagonal pyramid. So the base, isometric view of the base we will have to draw first, then locate the center of the base, and then from there erect a vertical line equal to the height of the axis of the pyramid, and that is your apex O. Once you have located the apex, join the apex with the corners, and again these edges are all on the back side, or they are hidden, which we need not show it over there. So now we will see how to draw the isometric view of a cone and a cylinder. So I am combining both cone and cylinder because both have a circular base, and that circle will become an ellipse. And of course I am not elaborating on the method of how to draw the ellipse because we have already dealt this earlier. So I have drawn the top and front views of the cone here. Obviously the top view is a circle of the given diameter 60 millimeters, and the height of the cone is 16 millimeters. So I have drawn the circle here and enclosed it in the box. I have marked all the points, and now I have transferred all the points here, all the 8 points here. Of course again I am leave the option to you whether you go for a points method or a four center method. So I marked this, and as we did in case of a pyramid, we need to locate the center of the base here, and from that point erect a vertical line which will be equal to the height of the cone. So this will be my this will be the apex of the cone. So here I have already marked the point, so I will draw an ellipse on a thin line. So having marked the ellipse, having drawn the ellipse, you need to connect this apex with the base such that this line connecting these two will be tangential to this ellipse. I am saying the word tangential because you should not connect the apex O with this point or this point. You have to connect it tangentially. Right. So I can see the other half of the ellipse is hidden, and this is the isometric view of the given cone. So having done this, now we will see how to draw the isometric view of a cylinder. So as I told you earlier, when you have a solid, assume that the whole solid is enclosed within a box. And so I have drawn a box here whose height is equal to the height of the cylinder. So again it has a base and the top face, you have two ellipses, and adopt the same method to draw the ellipse for both the base and the top face of the cylinder. Of course I am not elaborating on the method, I am not drawing the points, I will just tell you how to complete it. Right. So the height of the enclosing box, of course this square is this one, and the height equal to the height of your cylinder. So now I have drawn two ellipses, one representing the base, other one at the top circle. So again, of course when I see from the top circle will be fully seen, so I will darken that. Whereas the bottom circle will not be fully visible when you see from the at an angle. So just like in case of a cone where only half of the thing was visible, here also it will be the same. And having drawn these two, you need to connect these two ellipses using two lines which will be tangential to both the ellipses. So this is the isometric view of the given cylinder. So we have the base, the top face, and connect them using two lines which will be tangential to both the ellipses. Right. So in this session we saw how to draw the isometric view of the solids like prism, pyramid, a cone and a cylinder. But practically you won't be using full solids, and somewhere you use truncated solids. Probably in projection of solids you would have studied about certain things, or sections of solids you would have studied where a given solid is cut, the top portion is removed and you have the bottom portion. So similarly in isometric view also, how to draw the isometric view of truncated solids. So that we will see in the next session.